scripted. I mean, that's, okay, one of the main differences. All right, and so likewise then, if we're going to access an array, we're going to doubly subscript it. So for example, let's say I wanted to print this 9 right here out of matrix BB. Okay? I would say system out print, and I would say I'm going to matrix BB, and now I'm going to doubly subscript this reference. So if I want to print that 9, I've got to make sure that I'm going to row 2, column 0. Okay? Rows are always listed first. That's the rule. Rows before columns. So our first subscript is going to be the 2 for row 2, and our second subscript is going to be the 0 for column 0. Okay? And Java understands that we're listing the row first. So this is going to print 9. Okay, if I take that same print statement and I reverse it and I ask for 0, 2, that would print 3, because it would go to row 0, column 2. Okay, so if we run this code, we should first see a 9 print and then a 3. So we have to remember not only to doubly subscript, but we also have to remember that the row is always listed first and the column is always listed second. Okay, that's the way it was created to work. Okay, so if you ever want to access an array, you have to doubly subscript. Now, if we go back to matrix A from earlier, or AA, remember I said it was pre-filled with zeros? So if we went to AA and said, for example, like print element 1, 2, that's going to print a 0. Okay. If you don't want it to print 0, you can declare it to be something else. So we can assign it a value. So if I want to assign to a matrix, I can. Okay, what I do is I specify which value in the matrix I'm assigning, and then I remember that Java flows right to left, and then I can put any integer in there that I want. So if I want to put the integer 88, I can. Okay, so if I print this again, and I access that same value, this time it's going to print 88. So we'll see the 9 and 3 still, then we should see a 0 followed by an 88. Let's just verify that that's happening. Okay, looks good. So if you want to access an array, just doubly subscript it. If you want to assign to an array, you can. Okay, just like we did before. Everything in a matrix, everything gets 2 subscripts. That's the big difference. Okay? Now, what do you think is going to happen if I say, print, for example, BB, and I just tell the computer to print the matrix? Like, is it going to print, all 12 of those numbers? What do we think? You might be able to predict. It's not going to do anything real great. It's just going to print one of those weird memory addresses. So unfortunately, if we just tell the computer to print a matrix, we end up with some sort of weird memory address that's really of no use to us. It's not an error, right? It's not like it went out of bounds or did something weird. It's just when we print that memory address, it's really of no use to us. Now, if you remember, we had a way to kind of fix this before in the arrays class. What we did was we called the arrays.toString and applied it to that particular array. Okay, unfortunately, this isn't going to work. Now, the first reason it won't work is because I didn't import the arrays class. But even if I do, even if I import arrays, that's going to take care of the compile error. But when I run this, I'm still just going to, now I'm going to get like 4 memory addresses. The reason I'm getting 4 memory addresses is it's telling me the memory address of every single array within the matrix. So again, it's really no use to me, okay? Unfortunately. All right. And, you know, unfortunately, there's just no easy way to print a matrix. And there's not like a matrix.toString. If there was, I would show it to you. Okay, but there isn't anything like that. It's going to require loops to print a matrix. Okay, so, but part of the problem of writing loops for a matrix is you might not know up front how many rows and how many columns there are. So how will you know what indexes to produce to put in for the subscripts? Okay? Every time you access a matrix, you need two subscripts. So your loops are going to have to produce those subscripts. So you're going to have to know how many rows and how many columns there are so you know which numbers to produce and you don't go out of bounds. Okay, so we're going to use the length variable that we learned about previously in the arrays class. All right, so here's what we'll do. If I say system out print and I ask for bb.length, now, just like with arrays, that's not a method. So I don't put parentheses on it. It's a variable from the arrays class. It's not a method. So what is it going to print? You know, is it going to print 12 because there's 12 numbers in there? Is it going to print 4, the number of rows? Is it going to print 3, the number of columns? Oh, well, let's just find out. What's it going to print? Is it going to print 12? Okay, it actually prints 4. That 4 represents, okay, as you might guess, the number of rows in that matrix. In other words, it's how many arrays are inside of the overall array. There's 4 arrays within the overall array. That's the length of a matrix. So when you ask for the length of a matrix, you get back the number of rows in that matrix. Okay? Or another way to think of that is that it's the number of arrays within that matrix. There's another way to do this too. So I could also say system out print, and what I could do is I could ask for the length of a particular row. So for example, I could specify that I want the length of BB2. Now, what that would do is that would go to that particular row, row 2 of the matrix, and determine its length. Okay, there's 3 numbers in row 2, so this should print 3. That's the number of columns. It's also, another way to think of it is it's the length of that particular array. The array found at index 2 of the matrix BB. Okay, so let's just verify that this does print 3. Now, as you can see, it wouldn't have mattered which row I was talking about in matrix BB. It could have been row 0, row 1, 2, or 3, because all 4 rows had the same length, right? That's what made that a rectangular matrix. Now, if I was working with matrix CC, that wouldn't be true. It would now depend which row I was talking about, and I would get different values. Okay? So very important. We're going to see this throughout all of our matrix studies. Okay? 2 different ways to use the length variable. The first way told me how many rows there were, how many arrays were within the matrix. The second way told me the length of a particular row. By specifying which row I'm talking about, I can then determine the length of that particular row. Okay? So for example, if I asked for the length of, say, row 0 in the CC matrix, it would tell me 4 because there's 4 items in row 0 of the CC matrix. But if I asked for row 3, it would say 1. Okay, so let's just try that real quick here. So let's say we said system out print and we'll try two different rows from CC. So I'll say CC0.length. Okay, I'm predicting that that's going to say 4. But if I try that again, and I say give me the length of row 3, I'm predicting that's only going to be 1. It's going to have two different ones because this is not a rectangular array. Okay, so there's the 4 and the 1 that I was predicting. All right, we're going to use those two